friends. Today our topic is vertical motion of two bodies attached with an inextensible string over a frictionless pulley. We consider two bodies, body A which is heavier with mass m1 and weight w1 equal to m1g, and body B with lighter mass m2 having weight w2 and equal to m2g. Let these are attached with an inextensible string over a frictionless pulley. The string is inextensible, mean it cannot the length cannot be changed by applying force. Let body A is heavier, so it will move down. At the same time, body B will move upward because these are attached with a string over a pulley. Now let the forces on body A which causes it to move it downward. Let body A, according to Newton's second law of motion, which is F equal to ma, we have m1g greater minus t because t is smaller inside the string than m1g, so we get net result m1g minus t by subtracting greater force minus smaller force t, m1a. Here m1g minus t is net force, as F equal to in place of F in second law we pick m1g minus t as a resultant force, and in place of ma we here m1a because we are discussing m1 mass. At the same time, body B moving upward because m2g is lesser than the tension in the string T. In the string, net force on body B will be T is greater, which causing to move upward from m2g, which is the weight of the body B. T greater, m2g smaller, so net result T minus m2g is equal to m2a, which is second equation. Now adding equation, we have one equation and equation number 2. Adding equation 1 and equation 2, left side on left side and right side on right side, m1g minus t plus t minus m2g equal to m1a plus m2a. Here we take a common and t is cancelled with minus t, we get this. Here we again pick on this side and whole parts of the equation on this side. We cannot change the signs, so here we can take common a m1 plus m2 and we take g common m1 minus. Here we pick this factor and divide on this, we get m1 minus m2g divided by m1 plus m2, which is the acceleration of the bodies while body A is moving down and body B will moving upward at the same time with the same acceleration A. We have acceleration of both bodies by this equation. Now for the tension, divide equation 1 by equation 2. We have here m1g minus t minus m2g equal to this. A is cancelled with is, cross multiplying by have this cross multiplying we have this m1g and we multiplying this factor in this and we get this. We pick m1g m2g minus on this side, which will be positive, and here this negative on this side and it will be positive, and again we take common and we sum up these two time m1 m2g and t common m1 m2. Here we have t 2 m1 m2g divided by m1 m2, which is the tension in the string when both bodies are moving vertically upward and downward. A is moving downward while body B will upward with the same acceleration. From the above arrangement is also known as Atwood machine principle. It is used to find the value of g, which is the gravitational acceleration. So from here we can get this g by rearranging m1 plus m2, m1 minus m2 into a. We putting m1, m2 and values, and then a, we can get the value of g, which will be, it will be, if we take in kg, then it will be approximate 10 meter per second square value, or it will be, if we take in grams, then it will be 1000 centimeter per second square.